So in this lesson, I want to just go through base 2. I'm going to try to hit the highlights, show you how to convert to base 10, and then how to go from base 10 to base 2. So just a quick review here, and you can check out the other videos about base 10, etc. But the whole idea of any base number system is there's two main rules we have to follow. One is the whole place value setup. So place values can go infinite, but they always start with 1. All right, we have to set some rules at some place, and that's kind of our base rule in any base number system is first place value is always 1 because you always have to be able to represent the value of 1 some way, somehow. In base 10, that now determines how do I find my next place value? Well, you multiply by the base that you're in. So to find the next one, I multiply by 10. So the next place value is 10, multiplied by 10. Hundreds multiplied by 10, thousands, 10,000s, and you can infinitely go on with place values. The other half of the idea besides place values is what digits can you use to represent. So the general rule is in base whatever, you have that many digits to choose from to represent values. So in base 10, I get 10 digits to choose from. Okay, 0, we always have to be able to represent a value of nothing. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. There's my 10 digits. Okay, notice at no point can you use a digit equal to the base you're in. So at no point can I put the number 10 in a place value because it's against the rules. I can't have a double digit in a value, place value. So let's back all this up following the same rules and let's go to base 2. All the same rules apply, it just now changes out dealing with a base of 2. So in base 2, we'll start with a place value of 1, and I multiply by the base every time to find my next place value. So times 2. 1 times 2 is 2. Times 2. 2 times 2 is 4. Times 2. 8. Sorry, my marker's running out. 8 times 2, 16, 32, 32, 64, 128, etc., etc., etc. If you need more, just multiply by 2. As far as digits, it's base 2, so I'm only allowed 2 digits. Remember, I always have to start with a 0 to show a value of nothing. So 2 digits, there's 1. The only other one I'm allowed is a 1. So my only 2 digits I'm allowed is 0 and 1 because I'm only allowed 2 digits in base 2. Now, quick history, I'm not getting into it. There's a lot of people smarter out there that know way more, but this is the whole idea of binary code, right? Early computers used binary code, which is on-off. Simplest thing you can do is have an on-off setup, like a light switch, on-off. 0 is off, 1 is on, and if you notice on like any modern technology, the power button typically has a logo that looks like this. Something that looks like that, which is a hybrid symbol of the 1, which is the on, and the 0, which is the off. So I'll take you through converting a base 2 to a base 10. Just get another rag real quick. All right, so look, base 2 numbers, I mean, you pick it, doesn't matter. I'm just gonna pick a random one here. All I can do is make a number of ones and zeros. So let's go 1, 0, 1, 1, 0. Nothing too crazy. So the way I always work this is first, is take my base 2 number and set up the place values under each digit. In base 2, I always start with a 1, times 2 is 2, times 2 is 4. This is the 4's place value, this is the 8's place value, this is the 16's. So now what I need to do is figure out how much of each place value I have. Well, it's kind of like an on-off switch. Do I have any 16's? I have 1 16, so 1 times 16 is 16. Do I have any 8's? I don't. So 0 times 8 is 0. Do I have any 4's? I do. I have 1. 1 times 4 is 4. Do I have any 2's? I do. 1 times 2 is 2. Do I have any 1's? I don't. 0 times 1 is 0. So take the digit times the place value, multiply them all out, add them up. 16 plus 0 plus 4 is 20, plus 2 is 2. So this now gives me the value of 22. And that's in base 10. So 22 in base 10. Okay? The other way to think about it is special coins. Imagine that in base 2, each one is a special coin, like a penny, a nickel, a dime, etc. But it's weird coins, so it's a penny, a 2, a 4, an 8, a 16. And simply you just say, do I have one of the coins, yes or no? If there's a 1 above it, I have that coin. So lay it out on your hand, lay it out on the table, I have that much value. If I don't, if there's a 0 above it, I don't have that. So let me do a quick conversion the other way, and we'll go backwards to go base 10 to base 2. I don't know, division's not my strong suit, so let's just pick a number. We'll pick a random number, so let's go something like 78, and this would be in base 10. So now, if I need to fit it into the slots of base 2, I kind of have to look at my place values. There's a 1, 2, 4, 8, 16, 32, and what I try to do is list out all the place values up until without going over my base 10 number. So if I go a step further, 32 times 2 is 64. 64 times 2 is 128, so that's not going to fit, so I'm going to go here. Okay, so let's start doing some division. Can 64 fit into 78? It can. 64 into 78 can go one time. Subtract out, that gives me 14 left over. So I take that 1, transpose it up here. Take my remaining value. Remember I had a value of 78. I took out 64 of it. I have now a value of 14 left. Okay, can 32, can I represent 32 with that? Can 32 fit into 14? No, it can't. It's not, it's too big. So I skip that place value because I have no 32s. Can 16 fit into 14? Nope, too big. So I skip that value. All right, so next up, can 8 fit in? It can. So how many 8s can I fit into 14? Well, we know it's only 1. And guess what? If I divide out and I get anything more than a 1, I messed up somewhere. Because remember, the highest digit you can have in base 2 is a 1. So it makes sense that I'm either going to get a 1 or a 0 as my divide into, which base 2 is really easy because the math, the actually arithmetic of it's not very hard. So it goes in there, I get a 6 left over. So take that 1, transpose it up. Okay, I have 6 as my value remaining. Can I get a 4 into that? I can. 4 into 6, guess what? It better be a 1 or else we messed up somewhere. 1, 4, subtract, get 2 left over, transpose that 1 up. I have a value of 2 remaining. Do I have a 2? Yes, 2 can fit in. So 2 goes into 2. 1 time. I'm now down to a value of 0, so I'm done dividing out. Transpose that 1 up here. I have no value left. So how much do I have in the 1s? A 0. So that's a conversion base 10 to base 2. 78 the value of that is $78, whatever currency you want. Turns into 1001110 base 2. How would you check it? 2 plus 4 plus 8 plus 64 better give you 78 on the back end. So that's base 2. Hopefully that helps as you're working through it. Good luck.